Alright, seems like we're good. Let's see. Alright, got the chat up. Alright, let's go. Alright, so... Oh, I gotta get Cloud up too. Don't forget. Let's go. Alright, so... Last time we actually got through a little bit of it, so we implemented a couple structs for each stage: instruction fetch, instruction decode, execute, execute to memory, memory to write back. So we got those set up basically. Got the variables for like the current one and also changing the state of the next one for each stage. And let's see, what else? Yeah. We made like the different functions within the interpreter here. We had the fetch stage, and we actually like implemented the decode stage, and we ended off on the execute stage, which I have to implement today. So yeah, we can try and do that. Yeah, it seems like we did pretty good here, essentially. Right now we're just setting everything up for pipelining, but we haven't taken care of hazards, which we will do at some point. Alright, let's do it. Alright, so now we're doing execute, so we already have if the ID, X register bubble, I think it's X register bubble, right? Yeah. X register bubble, and the next one we set true, and then return if there's a bubble, so we don't execute any of this. Then we set up the instruction as usual, and I think that's good. And then setting up the variables for the ALU result and the ALUF result for the floating one. But now we have to actually, okay, so it's kind of similar to our switch statement here. We already had an execute here. Yeah, here. This was execute, but the problem with this is that we were actually implementing it where we write to the register as well, but we only want to store the actual ALU result. Writing is a later stage, write back. So we kind of just want to rewrite this in a way, but make it so that instead we actually like take care of this. So let's see. Let's just grab a couple. Let's just grab until XOR. Let's just see. Let's just try. So we need to rewrite these, right? So make sure we have this here, so that's working fine. And then keep moving down for each case. So our switch is for the name, so at I. So let's see how we have to actually do it this time. So instead of writing to the register, we want to change this now. We want to just store the value instead. Alright, let's see. So we need to store the value in here. So I guess we can take our AOU result and then take in the current value. So like just like here how we have our values, I guess we store them. So I guess just like this. So ID sub reg and then rs1 value. And since this is add I, we want to add the immediate value, so it wouldn't be in a register. I guess it'd just be just the immediate, I guess, right? Because we're already storing the variables. We're already kind of storing the variables anyways from the past in our struct. Because we're instantiating this struct, right? So yeah, so that should be fine, I think. I think that should work. And let's see what the rest do. So we can kind of get rid of this now. So we'll just store that and then break out. And then we have and I. It literally just be the same. Or rewriting it to be and. I think that's how we do it. Same with this case, it would just be OR. And then this one would be XOR. Just very similar. So let's see if we actually have something here. So check in to see. Bubble propagation. Oh, wait. Yeah, this should be X. I'm just putting mem. Yeah, that should work. Wait, so yeah. Logic looks correct. Including values from ID X register. Yeah, okay, so I think that's right. Yeah, I'll get to that after. Okay, let's keep going. Let's keep moving forward. We ended off with X or I, so let's do the rest of these. SRAI. Yeah, let's just do the rest of these and let's implement them. Alright, so we have those now. Alright, so okay, that's interesting. So ALU result is equal to, I guess we're still kind of static casting it, so let's see. So reading the register, we already implemented read for that anyway, so it would just be this value, rs1 value. That's less than JSON media, and then that's the same. So yeah, that's essentially good there. And then essentially just the same logic we applied to the rest. Let me just this part. So that would be, this one would be no static cast since it's unsigned. And that should be good, I believe. So we can get rid of, wait. No, but the static cast would be on the immediate, I believe. Let me go check again. Hold up. What is it? Oh, right here. Okay. Set less than immediate signed, set less than immediate unsigned. I think it'd be here. Alright, so we have a regular immediate, signed extended immediate, signed rs1, unsigned unsigned. Oh wait, I get why. Because immediate is inherently signed, I believe. Yeah. Yeah, our immediate signed, so we have to static cast that. So let's put that over. And then we can get rid of this. Alright, everything's good there. Alright, next let's do shift left logical immediate. Alright, looks like that one. Alright, let's write it. So failure result, we'd be taking the rs1 value and we'd be shifting that by our shift amount. And that looks to be good. Yeah. That's good there. And this is the same as this, just switching with the operator. Extraction operator. And then shift right, arithmetic immediate, that needs some static cast, so let's do that. Should be that. With, okay, static cast. This static cast is done on, let me see, the whole value, or is it? Because this is reading that, that's over that. Okay, so it's a static cast on this register, then we perform the operation, then we do another static cast back on top of that. Okay. I'll just copy. Yeah, I think I'll just do that. This one would go over here. And then when we're at the end there. And I think that static cast is done right. And then let's get rid of this. Alright, all these cases are done. Let's just do a quick check and then move on to the next instructions. Let's give it a claw and check real quick. what are the next ones we have to do? Alright, so we got through all the ones for I-type, the main ones. We have to go with the arithmetic ones. Now we have to rewrite these. So I'll copy them over. Alright, should be there. Alright, let's rewrite these. Let's see if Cloud has any complaints. Looking good. One thing to think about as you write branches in the pipeline. Okay, I'll get to branches later, but I just want to know if it's all good, and it's all good. Looks like it's good. Alright, let's do the add ones now. Add ones are pretty simple. We'll be taking the R1 value. So the A result be equal to the R1 value plus the R2 value. Just very simple like that. Nothing inherently difficult about that. Same for these, just changing the op. Oops, I copied accidentally. That should be 4 XOR. Let me make sure everything adds, subtract, and or XOR. Alright, that's good. Now let's move on to these ones. These are shift ones. Also pretty simple. Just shifting it. Right shift. Now this one needs to set a cast since we're doing on arithmetic. Shifting right arithmetic. Yeah, so that should pretty much just be this, but just with the same static cast representation we had before. Okay, wait, this one's a bit different now. Let's see. Static cast on this part. That's right. Edge. Cast. All right. I think that's good. It's ending bracket from that and that. Okay, I understand. So it should be 1 here, and then 2 here. Or no, just 1. Just 1. And we can get rid of that. Anyways, even if we miss something, Claude will catch it, so we don't have to worry too much. Shift less, set less than. Let's see. Alright, so this one will be okay, static cast. So static cast on this, and also a static cast on this as well. And then if that is 1, then otherwise it's 0. All right, that makes sense. Let's just look back for a second. Is that less than sign? We have to look on here for that actually. So less than, so it's assigned. Oh no, it's a different one. That's the immediate one. Yeah, here. So from sign compares writing 1 to RD if rs1 is less than rs2, 0 otherwise. Okay, yeah. These are both unsigned values, so that's fine. So yeah, we're static casting both. So this inherently static casts first value less than the static cast the second value. I think we need to static cast it back though, right? No, we don't. No, we don't need static cast back. I think it should just handle that perfectly. Get rid of this as well. So that's an unsigned. This is just literally just this, but just get rid of the static casts. Same here. Get rid of that, and it should reflect what we have. Okay, looks like it's good there. Can get rid of this part. Alright, that looks to be pretty good. I'm gonna check this real quick, make sure we have no errors, no bad things here. Good progress. What did he say about branch again? One thing to think about as you write branches in Python CPU, when a branch is taken, you've already fetched the next instruction or two into the pipeline. Those need to be flushed. Interesting. Branch flushing. Okay. Yeah, branch might be a bit harder than I thought. These ones are pretty relatively simple, but branch might be a bit harder. Let's just copy them over first though. Let's go up here and copy them over. Alright, so we have 6 branch instructions we need to rewrite here. These might be a bit troublesome, but we'll try and get through them. Alright, so let's see. Alright, starting with BQ. If the values are equal, we move the immediate by the immediate value. Otherwise, it just keeps moving forward. Hey, what's up, Ryan Silva? How you doing, bro? Alright, okay. What do we need to think about? What am I making? I'm making a CPU emulator for risc-v. Right now I have the decoder done, so it takes in like a random bit string, a 32-bit string, and then decodes the actual assembly instruction. Then we have the interpreter here that I also built. still in progress, but the interpreter basically mimics actual memory and registers, so it actually puts the values into registers for those assembly instructions. And right now we're focusing on the pipelining part of it, which is kind of hard, but I'm trying to do it. We're getting through. Okay, so branch. Okay, so how do we tell the CPU that we're taking a branch here? And that we need some space for the next instruction. Because if we have a branch here, let's say like we have a branch instruction that moves to like the 30th instruction or something, or the 20th instruction, we need to know how to get that to that. Yeah, I refer to like the documentation guides and all these different formats for the bits and stuff like that. And then if I really can't figure it out on my own, I use AI to help me just internalize it if I need to. Okay, I mean, okay, so I guess we can have like a like another if statement here, like a Boolean type thing. And we can set the branch target as like a different variable as well. So we can say maybe like bool, let's just call it like take branch. So, and we can initialize it as false as first. Nice bit out of my wavelength, but I'll stick around to learn something new. Yeah, I didn't know about any of this until like a month ago either, or like 2 months ago. I just started this project and learning computer architecture like 2 months ago. So we're just going through as I read and just trying to implement something. Alright, so we take a branch, and also we can set like a value. So let's say branch target. Let's call it branch target. So if we take the branch, we can set that to a certain value. Okay, so okay, so I guess we can reuse this part. Let's just take the rs1 values, replace these. So the rs1 value and also the rs2 value. Oh, what's going on? Oh yeah, it has to be in parentheses. Alright, so if the rs1 value is equal to the rs2 value, we're going to take the branch. So we can set the take branch equal to true and then move forward with it. So we can set branch target to, what would we set it to? I guess just this. Yeah, so our program counter plus the immediate. I think that's the right way of thinking about it. I'll check though. I'll check with Claude to make sure. And then if the branch is not hit, so if the statement gets to false and we don't take the branch, we have to, and I guess we just break. Yeah, I think that's it. We just move on to the next. So I think, let's see what Cloud says. The structure we need to pass take branch and branch target forward to X mount, so the memory state can act on them. Right now, they're local variables that get destroyed when the case ends. Add these fields to struct. Okay, yeah, I need to add them to the struct, I forgot. So in here, let's just set them here. I call it branch taken, right? Oh, take branch. Take branch. Something false. And same the other one, it was some int branch target. Alright, so branch target and initialize that. Should be good. And what did Claude say? That. Wait. Ah, I see. Okay. So we need to make the next value of that. The next value of that set to true. So no, it should be X mem because we're moving on to the next branch, right? Yeah, X mem. Yeah. Where's that branch taken? And same here. Branch target. And same. Yeah, we were close. We were close. I just forgot to put in the struct and then implement it into the next pipeline. I mean, not bad though. I at least had like the underlying logic correct. I just need to polish it. Save to true, save branch. I want to make sure everything's good. Branch target. Yeah, it looks like everything's good. Since we know how to do that now, we can write the rest of them pretty easily. So if branch is not equal to, so if the first variable is not equal to the second variable, we can just copy this pretty much and rewrite. So if it's not equal to, then we take the branch, set to true, it's pretty much the same. Okay, that's good. Next, branch of less than. All right, I want to make sure I check this properly. All right, so if the first variable is less than the second variable. All right, static casting or static casting. Oh yeah, this is because it's signed values. It's signed values, I believe. Let me check here just to confirm. Using signed comparison, yeah. And this is unsigned comparison, so we do need to make that static cast. That makes sense as to why. So checking the static cast values for these. And if that's true, we take the branch, or else we just break. And this one is pretty simple. I'm just gonna copy this over. Since we're already working with unsigned values, we don't need to change anything. We don't need to set a cast. Branch of greater than or equal to signed comparison. Pretty much it's this. Oh yeah, I forgot to change this. Less than unsigned, greater than or equal to, and then lastly greater than or equal to unsigned, which sets the value here. It should be good. It was a bit difficult, but I think we got it. I think we got it through. Alright, let's just check these cases. Remove the unused local variable take branch. Oh, wait, did I not remove it? Oh yeah, you have to take them out. And the branch target, right? Yeah. Alright, I'll take them out of each instruction. Alright, we're good now, I believe. Let's move on to the next ones. Let's see what the next ones are. Alright, JAL, jump in link. Let's do that one first. Alright, jump in link. So let me read the document for this again. Jump in link. So okay, setting the offset value for the label that we're jumping to into the destination register. So this would be like for function calls. Okay, let's see. I guess. I mean, this is also kind of like a branch type of thing. Sorry for interrupting your thought process. If you don't mind, could you share where to even begin so I can follow through? It seems very interesting. Yeah, I'll show you. So I started with this book here. I got like a couple chapters in. I'm like on chapter 4 right now, in the middle of that. That's where my pipelining is going through right now. So I'm reading that and implementing. This basically teaches you like everything about the assembly instructions and everything that's going on here. The ALU, control and data path, floating point instructions, everything like that. And then you can like look up guides and try to implement them into code on your own. Like I have these guides. You can't really memorize these. I mean, you can, but there's no point in memorizing them. So you use these guides to actually implement them into code, depending on the layout of bits. And the book also teaches you like bit addition, bit subtraction, bit multiplication, so you can actually implement all these in code. And yeah, that's pretty much what you can do. And once you start the project, you'll start to get the hang of it. Because I did not know any of this before I started, but once I started the project, I slowly got the hang of it. And you don't have to be perfect on the first write of your implementation. Like you'll most likely write like a sloppy code for the first time, but like it's fine if you have that. You can always rewrite later, so don't be afraid of the first write because you think it's not perfect. Alright, so let's go back to this. Alright, so jump in like is kind of like a branch as well. So Yeah, I guess this one doesn't need to check anything though. We're not checking any if statements, so I guess we're just gonna do like, let me see. I guess it'll just be like, reg take branch. Let's just take branch equals true, because we're gonna take the branch no matter what. In this case, we're not comparing anything, so we're taking the branch true, and then also what else? The branch target, and we want to set that branch target to just the same as this pretty much, but it'd be +4, not the immediate. +4 first, semicolon, and then we want to set the PC value. I guess the PC value. Reg.pc, and do we increment that by 4 right now though? I mean by the immediate, not by 4, but I feel like I'm doing something wrong here. Better PC value plus PC. Yeah, I probably got one thing. I feel like this part might be wrong. Not by 4, by the immediate. I think it still might be wrong though. Let's see. Program counter. So how do we store the program counters again? We stored a variable to that, and then PC commit by 4 for each instruction. I think that's fine, but I just want to check just in case. Branch checker form is wrong. So what Java does, return address, PC was 4. You have them swapped. Okay, so let's see, let's compare. So take branch equals true, that's right. Take branch target. Yeah, that's okay. Wait, hold up. Let's go back. PC plus 4, PC plus offset. Wait. No, that should be right? PC plus 4. And then the program counter is by the offset. Wait. Let me confirm with Claude to be sure. Let me copy this implementation here. You're right, I already had correct. Let me clear. Return address stored in RD via write back. Might be from looking at my earlier message where it said you haven't swapped. Branch target. I need to look at this more. Hold up. Storing. Oh no, I get. Okay, I get it. I get it. Alright, yeah. The ALU result is what is stored in RD. Yeah, I had them swapped. Okay, I get it now. I get it now. Yeah, so that's what was going wrong. So we want this one to be by 4. And this one to be the widely immediate. So I can take that branch. Alright. Yeah, not gonna lie, pipelining is kind of confusing so far, and we haven't even gone into the hazards yet, so it's gonna be quite interesting. Alright, JALR. Let's do JALR. JALR. Alright, let's see. Let's go back to the implementation. Alright. So destination register is the same. Storing a program counter incremented by 4. But in this case, program counter is the rs1 value that's stored in rs1 by the offset, by the immediate. Okay. So let's just go with the same here. Let's see. Take branch. Yeah, but instead of here, we need the rs1 value. So we're taking the rs1 value plus immediate, and then ALU result is the same. Okay, that's good. Alright, next one. Next one, load byte unsigned. I'll check out your past streams and go through the book as well. Hopefully I'll be able to catch up your next live with some understanding. Thanks for sharing. Alright, man, I appreciate it. Hopefully we can get this emulator written out. And then I kind of want to move into compilers because this is very closely linked with compiler stuff. So after this book finishes, I want to get into compilers and then hopefully have the compiler project very linked with this one. But that's for the future. We don't have to worry about that right now. We just gotta keep writing this. Alright, load byte and all the load instructions. Yeah, this part's gonna take a while to write because yesterday or 2 days ago, we wrote the decode and the fetch stage. And I already did write the execute, but the problem is in this case, in this execute function, we're also doing memory and write back, which is 2 separate. So I need to rewrite this by splitting it up into 3 different parts for pipelining to actually work. So I'm just trying to rewrite with my new implementation. It might take a stream or maybe 2 streams to get that. And we still have to work on hazard logic too. Hazard logic and the stalling, forwarding, all those implementations. So it's gonna take a while, probably maybe a week or 2. But yeah. Wait. go back to the load instructions. Let me see. I'm pretty sure we moved these to memory. So like, I think we wouldn't actually like read anything here. And we wouldn't write anything either, so wait. What are like the implications of it? Did Claude give me any ideas here? Oh, I see, okay. So we're just calculating the memory offset, essentially then? Let me see. So for the load instructions, memory from the memory address of RS1 and the offset, and we're loading that value into destination register. So I guess we're just calculating the offset here. We're calculating the memory, not the offset, the memory. Interesting. And then the memory stage, the next stage, will handle that, so. So like literally all of these will be like the same. Let me just get these over. So we're just allowing this one to compute the value in the LU. I believe I wrote it in my notes, I believe. Let me open up a studio real quick. I believe I wrote it in my notes here. Why we're adding this, because the address offsets are calculated through addition. If you have offset of 12 in x6 register, it'll be equivalent to x6 plus 12, so we need the ALU to add here to calculate that immediate value. Okay, so that's why we're storing that in the ALU result for it to calculate first. And I guess that would be the RS1 value. So let me just copy this over that and the immediate. Alright, so just like that. And the same pattern for literally everything. Every single one of these should do the same exact thing. Now for this one, it's a bit different though, is it? Let's see. No, not really, it's the same. It's just that it's the reverse way. We're storing from memory to a register. So it's the same. Oh yeah, I think I'll check. Let's check the whole function now so far. make sure we're good. Jump in link register missing LSB clear. Load and store can be consolidated. All 5 loads and all 3 stores can be the same address formula. You can use fall through to avoid repetition. Let me actually check. Does fall through? I have a couple questions to ask. Does fall through? And also another question I had. Let's see. I don't recall ever doing this before, so I need to actually understand what that is. What is the LSB clear? Fall through has 0 effect on time complexity. It's purely a code organization tool. Compiler sees multiple cases with no code between them and generates the exact same jump table entry for each. At runtime, it's a single jump to a shared code block. No performance difference whatsoever. Oh, least significant bit. It's 0. Clearing the LSB means forcing bit to 0. The reason JAL jump in link register requires this. The spec says the target address must be 2 byte aligned. Oh, does it? Okay. Okay. It's a hardware guarantee that prevents jumping to an odd misaligned address. Wait, did I do that? An original JLR? Oh, I did. I totally missed that. I actually totally missed that. I forgot. Okay, JAL R. Alright, so it needs this value here to be ended. Alright, yeah, that's good. That should be good. Okay. And then, yeah, I guess as Claude says, we can just fall through so we can actually get rid of these. So we'll just end up falling through. So now that's good. Just following through all those. Should we, okay, we should still distinguish though before between these. Alright, let's see. Let's take a look. I have a feeling this Claude chat's about to end soon, to be honest. I feel like I've queried a lot. Okay. Even the braces too. Interesting. When you have no code between them after braces. Okay, even this one too. Okay. Some value plus intermediate. And yeah, we want to separate these two. Okay, that should be good. Alright, let's do the next cases. Here we have AUIPC and load upper immediate. Let's see. Okay, I might just end the stream, to be honest. I think we've done considerable progress today. I think we can just pick up off tomorrow. The rest. I still got a couple of work to do for school, so yeah. I'll just end the stream for today.